This video will demonstrate a laptop using Linux connecting to a Raspberry Pi remotely, which is controlling an Elecraft K3S. Raspberry Pi already has realVNC in the repositories, and it's free to use. So we've already got that set up here, so we'll double click. And we're connected. So I'm in one room and the Raspberry Pi is in the other, and that Raspberry Pi is connected by a USB cable going to the back port, the USB port, serial port, sound card combo on the back plate of the K3S. So first on the Raspberry Pi, since we're using Jack Audio, so we can use Zita-J2N and Zita-N2J to stream the audio from the Pi over to the laptop. The Elecraft has its own sound card, and that's what we're going to use in Jack Audio here. We're also going to use the Pi's own analog audio output, that little speaker jack, to send audio to a audio-derived CW keying switch circuit. And that's what keys the K3S's CW jack. So we're going to use Q Jack CTL to get started. And in the setup, we're doing a duplex with two different sound cards. We're using the ALSA driver. I'm using the -S for synchronized server mode, something like that. And there's another video that explains this more in depth that'll be in the show notes. So I won't go over a lot here, except that the sound card is showing up. Here's the duplex part, and over here the USB sound card that's in the K3S registers as this codec, USB audio codec here. So we've chosen that as the input device. The output device will be the Pi's own sound card, this BCM2835, that top one there. The lowest latency I could get to use on this Pi, it's a Pi 2B, was sample rate 48K, frames period 480, and 4 periods buffers. And that's the lowest I can do, and it's good enough. So we'll go ahead and get started here. And click Start. And hopefully everything will go okay. There we go. So the system on the left is the incoming K3 USB audio sound card. Sound card on the right is what any of the directed audio will go to that Raspberry Pi analog sound card, and then out with an audio cable that connects to the input of an audio-derived CW keying switch circuit. The output of that grounds the CW keying jack of the K3, and just like you would normally do with a straight key. So we'll expand this. So now how do I get audio from this Raspberry Pi to my laptop, and from the laptop back to the Raspberry Pi? That's where this Zita A2J and Zita N2J, N2J and J2N. So I've already got that hooked up here. Before we do this, let's go ahead and get the control of the Raspberry Pi so we can see what the frequency is. And now we're going to use GRIG. And GRIG is a free Linux app. It also works on the Pi. And there's the command structure right here, GRIG-M229, which is the model number of the K3 that's registered in the GRIG software. The -R tells it where that serial device is, which is a USB serial. So we have /dev/tty capital USB 0. So we'll kick this in and see if everything goes according to plan. And there it is. So it's already on 40 meters at 7031. And by left-clicking, you can raise that number. Right-clicking, lower the number. You can do that on any of these digits. You have CW mode, USB that you can select over here. It's a very simple, but it works pretty well for my use. All right, so let's see if we can get the audio now. So one of these brings audio in, the other one takes audio out. So let's take a look here. We'll repeat this one on the left. Now the command is Zita-J2N space the IP address of this laptop and a port number. So 5000 is the port. So we'll go ahead and enter. Now all the audio I want to send from the Raspberry Pi can connect to this right here. And now I should be able to hear it. So let's go ahead and get set up on this side. And we'll do that. There's that same port number. So I'm going net to jack. So from the net, the other one was going jack to the net. So this one's going N2J, the IP address of the receiving and the port number of the receiving. Those should be the same. Receiver and sender should be the same. So let's hit that. And let's see if it shows up. And there it is. So I'll hook it to my sound card first. And then to yours over here. There it is. Left or right channel, and then the other one. So now we are receiving audio from the Raspberry Pi using Zita-N2J and Zita-J2N. So let's go back to the Pi and scan here a little bit. And we'll just go up to 3, scan up. There we go. Okay, so now we'll go ahead and get this audio and disconnect it for now, and we'll try to go to the other way. And the reason we want to send audio from here to the Pi is I'm going to send a CW tone over to the Pi. It's going to receive that tone and send it out its analog sound card to that audio-derived CW key switch, which then keys the rig. I'll get that set up here in just a second. So let's go ahead, go back to the Pi, and get this second one set up here. Again, we want to receive audio, so it's from the net to jack. So it's Zeta N2J-N2J. This would be the IP address of the receiving part and a different port number. So we have the 130 is the Pi, and let's go ahead and register that, and there it is, showing up in the connection bay. So we want this audio to go to the Pi's own sound card, and then go out that audio cable to the audio-derived key switch. We'll hit connect. And now we're going to go back and run the other one. So now I want to go from jack to the net, and I want to go to the Raspberry Pi and to its port number 5001. And there it is right there, over here. So let's go ahead and do a test setup here. I'm going to change the frequency. So let's go up a little bit. Now I'm going to get FL-Digi. FL-Digi has a QSK write control, which is perfect for this operation. So we'll go get the modem. We're going to QSK on the right audio channel. This sends a 1K tone, and you can adjust and trim down or add to the weight of each element with this control. So I'm trimming off 5 milliseconds. You can also adjust the volume, which is down here, so I'm at -19. But it's at full volume coming from the right channel. So here is FL Digi. I'll hook it up where I can hear it, and then again to the screen recorder so you can hear it. And we'll test it first. Hit the TR button, and let's lower this down to about 20. Here we go. So we'll send a T. All right, now let's see if we take the right channel and send that 1K tone. Let me see if I can let you hear this without blowing your ears. So I'm going to send it over to the mic input here. So you heard both of that. So that upper tone is a kind of a square wave, or it's actually a 1K hertz with no rise or fall time. It's at 0 rise and 0 fall, so it has a lot of key clicking. But that doesn't matter for that key, for the key switch circuit, the audio derived key switch. So let's see. Send a QRL here. And you can probably hear the receive audio in between there, so it is working. And now all we have to do is adjust for the volumes. We can stabilize the volumes further with some other applications. But that's just the basic setup here that for remoting in, getting the audio to work. On remoting in to a K3S Elecraft, using the Raspberry Pi and a laptop using Linux. This is using, the Pi is using Raspbian Jessie. Thanks for watching.